Okay, this is going to be lesson 5.1 notes. And in 5.1, what we're going to be looking at is slope and rate of change. Okay? So now rate of change is just slope. It's the same thing as slope, but it's dealing with the real world. And so when we deal with the real world, a lot of times we're going to put it in decimal. And really, I should have also probably went ahead and put decimal or whole number down here. So it'll be usually decimal form or whole number, just depending on the problem. All right, but it is slope, just more in real world context. Okay, so rate of change shows the relationship between two, and that's TWO, that was a typo right there, between two changing quantities. Okay, and we'll look at an example here in just a second. All right, where slope is simply just the steepness of a line. How steep is your line? Okay, now, there are a couple of different ways we're going to find slope, a couple kind of different formulas, so to speak, we'll use. All right, the first one being rise over run. So we'll take a look at this as when we're just looking at a graph and we're counting rise and run. It is also known as your change in y over your change in x. Okay, so these are kind of the same thing, but you're going to hear a lot of rise over run. Then they're going to give you coordinate points without a picture, and they're going to actually ask you to find slope using the formula. Okay, so M means slope, all right? M means slope, and it's y2 minus y1 divided by x2 minus x1. Okay, so coming down here, first off, just kind of a did you know kind of fun fact here, that the reason we use M for slope is because it's coming from a French word, I don't know how to say this exactly, monter, which means to climb. All right, so if we're looking here, we're like climbing uphill, right? If we look here, we're climbing downhill. So that's just kind of a fun fact on where M came from and why we don't use like maybe an S or something like that for slope. Okay, all right, so now kind of coming down here and looking at this. This is kind of important stuff right here. First off, you're always going to read your graph just left to right, just like you would read a textbook, okay? So if we're going uphill, that is going to be a positive slope, okay? If we're going downhill, so when I read across, I'm coming downhill, that is going to be a negative slope line. Now, if I have something that's no hill at all, so like you're just walking across it, you're not going up, not going down, that's going to be a slope of 0. Okay, and then on for our last one here, when we look at this guy, I can't walk up and down that. That's up and down. That would be like me trying to go up the side of a building, all right? Well, that's not going to work so well. So when it's vertical, we get this is undefined. Okay, your slope will be undefined there because it's not flat. It's not something we can walk on. All right, so let's kind of go down to the next page now. And what we're going to look at first is, it says a table shows the distance a band marches over time. What is the rate of change? Now, this is really important here, okay, because rate of change would be telling us it needs to be in a decimal form. And then we'll talk about, like, what does this represent? So we already have taught you how to tell if something is linear, right? Linear or nonlinear. So when we taught you that, I would say, well, you're going to look at your x's and just make sure that you've got a pattern here. So if I look here, I'm adding 1, adding 1, adding 1. And then we would do the same thing here. Is there a pattern between each number? So in this case, I'm adding 260. I add 260 and add 260. And so when we taught this earlier in this chapter, we told you that this was linear. And what we were starting was we were starting the idea of slope, okay? So if I kind of go back here and look at this first guy, looking at this guy, we would have the change in y over the change in x. Well, that's what we're doing when we're looking at our table and trying to figure out how much is it going up or down by. So if I think about the change in y, right? So change in y, well, that's going to be my change in y's are going to be the 260s. I'm adding 260 every time over the change in x, which in this case just happens to be 1s. All right, so now since it says rate of change, right, up here at top, it says rate of change, that means I either need a decimal or a whole number. So I'm actually going to go ahead and just divide this. Obviously, 260 divided by 1 would just be 260. And now kind of put your labels on it. All right, so if I'm looking here at the 260s, that's my distance. All right, so in this case, it would be feet. Remember, this fraction bar means per. And then on this last guy here, when I'm adding 1, those are minutes. All right, so it's going to be feet per minute in this case. Feet per minute. So now, when you actually come over here, you need to put your label on it. So it's going to be 260 feet per minute. Okay, and that is going to be your answer right here. Okay, so now what does this mean? All right, when it's asking what does this mean? Well, since we're talking band distances and how much they march, they're marching 260 feet for every minute that they march. Okay. All right, so that's kind of where we are actually already working on linear, and that's kind of how it's all connected to slope. All right, so now they're also going to just go ahead and give you a picture. All right, so here, all you see is pictures, and they're going to ask you to find slope. Now, this is where we're going to focus in on our rise over run. Okay, so rise over run. Now, when we're talking slope or the steepness of a line, it's actually just triangle work. How much are we rising? How much are we running across? So slopes actually have to deal with triangles a little bit. So rise, how many did I go up right here? Well, I went up 2, so I got a 2 here. And then run, how many did I run across? Well, in this case, I ran across 5. So my slope will be 2/5. And then if I think about, just kind of double checking, if I read it across this way from left to right, okay, that's going uphill, so it should be positive. So my slope here is positive 2/5. All right, let's go to the next one. Again, let's go ahead and make our triangle. Okay, so I'm going to rise, and then I'm going to run. Now, when I count this out, my rise is 2, and then I'm running. Now, I need to be careful here because I'm actually running this direction, and since I'm running this direction right here, that's actually going backwards. It's going towards the negatives. So my run across is going to be a -6. So when I do rise 2, I'm going to run -6. So now you do need to reduce your fraction here. So when we are asked for slope, we're going to leave it in fraction form. So it's going to be -1/3. And that's going to be your slope. Okay. All right. So now if I'm looking at this, I've got a horizontal line. And it'll be really helpful if you just kind of know a horizontal line is equal to 0. Just kind of have that memorized. Now, if not, guess what? Rise over run will still work. If I'm thinking about it and I'm looking here, I'm going point to point. In this case, there's no triangle. I'm going to rise 0, and then I'm going to run across. Well, if I look here, I run across 5. All right, so 0 divided by 5 would be 0. Okay. All right, so now looking at this guy, like I said, it would just be helpful if you just knew that vertical lines were undefined. Okay, so we already know our slope here is undefined, but let's talk about it in case you don't remember that. How would you figure it out? Well, again, you're going to do rise over run. Now, in this case, I am rising 3. All right, so I'm rising 3. I'm running side to side. No spots, so I'm going to put a 0 there. Now, take a second, pause this video, and I want you to go ahead and put in 3 divided by 0 in your calculator. And just see what it says. Okay, so if you went ahead and paused and put that in your calculator, a lot of you probably got some sort of error message. Okay, so math error, maybe domain error, can't divide by 0 error type message. Okay, and so when you get that error message, that's your undefined. So if you can't remember, like if you're counting it out and you can't remember which one's which, all right, when you put this in your calculator, and you can go ahead and do that real quick, 0 divided by 5 will just give you a 0. Okay, but when I take 3 divided by 0, I'm going to get an error message. Okay, all right, let's go ahead and go to our next one now. So now they're not going to give you a picture. Now they're actually going to ask you to use the slope formula. Okay, so I'm going to kind of put the slope formula up here at top just so we can remember what it was. Okay, but slope, so m equals y2 minus y1, again, change in y, over change in x, so x2 minus x1. All right, so when you're doing this, what you're going to do is the first x you come to, you call it x1. The first y you come to, you call it y1. And then x2, y2. Okay, now it's just a matter of plugging it into the formula right here. So y2 is -2 minus your y1, which would be 0. So you're going to set it up -2 minus 0. So again, notice I'm just going from here to here. All right, that's all that's happening there. Over, and then x2 is 3 minus your x1 value is -1. So be careful there. You do have a double negative there in the middle. Okay, so now when I simplify that, I get -2/4, which would reduce to -1/2. Again, when they're just asking for slope, keep it in a fraction form. Okay, all right, let's go to the next one here. So again, x1, y1, x2, y2. All right, so now go ahead and start with your y's. So y2 minus y1, so -3 minus -3 over x2 minus x1. So I'm going to have 5 minus -1. So now, double negatives become positives. -3 plus 3 is 0. 5 divided by 1, or sorry, 5 plus 1 is 6. So 0 divided by 6 will be 0. So that's your slope. Okay? All right, pause the video, and I want you to try to do C on your own now. Okay, so when you did this problem, you should have set it up 9 minus 7. Okay, so again, y, right? Subtract your y's. So 9 minus 7, and now subtract your x's. -3 minus 5. So -3 minus 5. So on the top, you would have got a 2. On the bottom, you would have got a -8, and that's going to reduce to -1/4. Okay? All right. Example 4, please do not worry about. So go ahead and just skip that. And let's go to example, oh, I guess I got another example 4. And let's go to the next example 4 there. All right, so now this is a real world problem, okay, not in table form like our first example, okay? And so the question is, or the problem is, in 2000, there were approximately 75 students in the Cathedral High School band. In 2019, the number increased to 105. Find the annual rate of change. Now I'm going to highlight that because that's pretty important. Rate of change, right? And so that's, just as a reminder, that's telling us it's going to be in decimal or whole number form. Okay, so not fractions on that rate of change. Explain what it means, and then we're going to identify the independent and dependent variable. Now, when we're talking independent and dependent, we talked in class a lot that time has to be x, right? So independent, we talked a lot about that. Time would always be your x value. Okay, so in this case, in 2000, there were 75 students. So really, you already have your coordinate point set up because 2000 is time. It has to be your x value. And then whatever else we're looking at is going to be your y. So in this case, 75 students. So then in 2019, there were 105. Okay. All right, so now let's go ahead and set up our slope. Okay, rate of change is just slope. So we're going to start with our y2, right? 105 minus 75. And then I'm going to take that 2019 minus the 2000. So 2019 minus 2000. So now on top, I get a 30. On the bottom, I get a 19. Now again, the difference here is we have to go ahead and divide this out and get an actual decimal answer. Don't leave it as 30 over 19. So when you take 30 and divide by 19 in your calculator, you're going to end up with 1.58 rounded off. Okay. Now you give me 1 or 2 decimal places, it's fine because the directions didn't specify what to do there. So just as long as it's rounded off correctly, I'll take either one. And then let's come up with our label. So if I'm thinking about, whoops, it's like 75, right, and 105. So if I'm thinking about these top numbers here, that would be like students or band members, however you want to say that. So I'm just going to put students per, and then I've got years on the bottom, so per year. Okay, So now, what does this mean? It means that my band is increasing, because it's positive, increasing by 1.58. And I'm going to go ahead and put my label over here, students per year. And that's my rate of change, or slope, okay? Now, the last part here is find independent and dependent. Well, we kind of already talked that independent is your time, okay? So if we're doing time here, we could just say years or time. I would take either one. So years. And then your dependent, again, is just whatever else we're looking at. In this case, we're looking at students or band members. So again, band members or students, it's up to you. Okay. All right, and that concludes Lesson 5-1 notes.